Hello, welcome to ANS Solver. This is the third question of the paper. So here we need to prove that f theta can be written as 1 minus cos 2 theta. Okay, it can be written as tan theta. So you need to know 1 can be written as sine square theta plus cos square theta. Agreed? Cos 2 theta can be written as cos square theta minus sine square theta. And sine 2 theta can be written as 2 sine theta cos theta. So expanding this, I can write this as sine square theta plus cos square theta minus cos square theta minus sine square theta plus 2 sine theta cos theta over, in the place of 1 I can again write sine square theta plus cos square theta plus cos square theta minus sine square theta plus 2 sine theta over cos theta. So now what I can simply do is I can write this as sine square theta plus cos square theta minus cos square theta plus sine square theta, okay, plus 2 sine theta cos theta over, I can simply cancel sine square theta here and add cos square theta and cos square theta to get 2 cos square theta plus 2 sine theta cos theta. Now here also I can cancel cos square theta and cos square theta and add the sine square theta and sine square theta to get sine square theta plus 2 sine theta cos theta over 2 cos square theta plus 2 sine theta cos theta. So now I can simply take 2 sine theta common here to get sine theta plus cos theta here over, I can take 2 cos theta common here to simply get cos theta plus sine theta here, where I can simply now cut this and I can simply cut the 2 to get sine theta over cos theta, which is simply tan theta, which is what I needed to prove. Okay, now integrate f theta, okay, with the limits 1 over 4 pi and 1 over 6 pi. So I can basically integrate 1 over 6 pi, 1 over 4 pi. I know f theta is basically my tan theta d theta. So now I can write this as 1 over 6 pi 1 upon 4 pi. Tan theta can be written as sine theta over cos theta. Now I can simply use integration by substitution here, where what I can do is I can take the denominator as u. Okay, so my du by d theta is the differentiation of cos theta. What is the differentiation of cos theta? Minus sine theta. So I can write this as du by minus sine theta equals to d theta. Okay, so why did I do integration by substitution? Because I know when I differentiate cos theta, I'll get a minus sine theta, which I can simply cancel. Okay, even you can, use the mechanism something like that. So I get sine theta. Okay, now what you do is don't write the limits because I'm writing in terms of u, so I can't write the limits. So it's sine theta over u into, instead of d theta, I can write this as du by minus sine theta, where I can cut the sine theta to basically get the integration of, I can take the minus outside and 1 over u du. So basically when I integrate this, I get minus of ln u. Now I know u is simply cos theta which we took here. So ln cos theta, now I can write the limits, which are 1 over 6 pi and 1 upon 4 pi. So now I can write this as minus ln. Now in the place of theta, first put 1 upon 4 pi. Make sure you're on the read-in mode. So it's cos of 1 upon 4 pi, which I get as 1 upon root 2. So this is 1 over root 2. Minus ln of, now instead of 1 upon 4 pi, write 1 upon 6 pi. So I get root 3 by 2. So now I can use the log property, which suggests that log of log A minus log B can be written as log A over B. So using that log property, I can write this as minus ln 1 over root 2, okay, divided by root 3 by 2, where I simply get minus ln 1 over root 2 into 2 over root 3. So now I can write this as minus ln. I can simply cut this and write this as root 2 by root 3. But now, what do I need to prove? I need to prove this. Okay, so what I basically do is, see, you need to know, I can basically write this as ln because I need a positive here, correct? I know one property which states that, I'll go with you step by step. I know one property which states that b log a can be written as log a raised to b. So now I can write this as ln root 2 over root 3 raised to minus 1. Basically the minus 1 is the b. Now I can write this as ln root 3 over root 2, where the minus 1 goes away because I have reciprocated. Now I can write this as ln whole root of 3 over 2, which now can be written as ln 3 over 2 raised to half. Agreed? So now using this property to this property, because it's vice versa, I can simply write this as half ln 3 over 2, which is the final answer of my question. Okay, so simple logarithm properties to get the answer.